Hi everybody, welcome to this introduction to linked lists. We're going to be using a regular array data structure to help us implement a linked list, but arrays and linked lists are two completely different data structures. Remember that in an array, if we want to process the array, we start at index 0, or whatever the first index is in the array, then we go to the next index, which is 1, then we go to the next index, which is 2, then we go to the next index, which is 3. So all the elements in the array are collected just side by side. So it's very easy to process the array. That kind of arrangement is known as a contiguous data structure. All of the elements in the array exist side by side in computer memory. Okay, so that is a contiguous data collection. A linked list is a little bit different. So using this array, let's just have a look at a linked list. Okay, here we go. The first thing we need to understand is that in order to process a linked list, we need nodes. So here we have a linked list of nodes. Each node in the linked list has an item of data, for example, 13 or 15 or 21. It could be strings, could be anything, but we're looking here at a linked list of integer data items. Each node also has a pointer to the next node in the list. So remember, with arrays, the next node in the list would be at index 1, and then it would be index 2, and then it would be index 3. With a linked list, it's different. This next node pointer tells us where to go next. So node 0, the next node is node 1. The next node is node 4. The next node is node 2. The next node is node 7. This is us going through the list in order. We're just following the nodes. The next node is node 3. And the next node, well, there is no next node. We have reached the end of the list. So in this collection of 10 nodes, the active nodes in the list are 0, 1, 4, 7, sorry, that's not true. Let me start again. 0, 1, 4, 2, 7, 3, and that's the end of the list. We're not using nodes 5 or 6 or 8 or 9 in this sample here. We'll get to that later. Now another thing that we need to know is that let me just get rid of that. First node index, which in this example is 0, this is known as the root node. This is the root node. This is the start of the linked list. We call it the root node. And 0 is the root index value. I'm just going to call it the root pointer. That's 0. So if you see the word pointer, we're usually thinking of an index number, an integer. Okay? So there's an introduction to how a linked list can be constructed on top of a regular one-dimensional array. Now, rather than us spending the next 20 minutes hopping around this linked list, I'm just going to reorganize it so it's a little bit easier to look at. So what we've just decided was the node at index 0 points to the next node, which is at index 1, which points to the next node, which is at index 4, which points to the next node, which is at index 2, which points to the next node, which is at index 7, which points to the next node, which is at index 3, and that's the end of the linked list. Now within the array, there are some empty elements that we're not really using. There's no data or useful data, and it's not a part of the list. I'm going to call this the free list. And I'm just going to make sure that I identify the start of the free list. It's here. 5 points to 6, 6 points to 8, 8 points to 9, and 9 is the end of the free list. Now we're not going to be talking about the free list in this video, but that's an important concept for you to grasp. If we're implementing a linked list using an array and we have some spare nodes that aren't being used for anything, or some spare indexes which are not being used for any purpose, we can call that the free list. Now our challenge, of course, as we get started, is to loop through our list and print out every data item in the list. So I want to print out 13, 15, 17, 21, 23, and 29 in that order, because that's the order of the linked list according to the pointers that we are using. Okay? So what we're going to do, we're going to set up all of these nodes by following this design here, and then we're going to push those nodes into an array to create our linked list, and then we'll process the linked list. Okay, so let's have a look at how to do that. Here you can see I've designed the node class, and I've just set up two attributes, data and next. And that's really what these are, data item and next node. Okay, so I've got my node class. Now I'm going to design all of the nodes in my 10 element class. And all I'm going to do, guys, this is relatively straightforward. Node 0, or the element, the node at index 0, has a data item of 13 and a pointer of 1. So that's what I'm doing here. The node at element 0 has this data attached to it. At node 1, we have the data item of 15, and the next node is 4. The next one at 2 is 21 and 7, etc., etc., etc. So I'm just creating all of these nodes so that I can get started by constructing a linked list. And I'm going to be using an array to do that. The purpose is really we want to use the power of indexes, even though we're using a linked list. So let's push all of these nodes into the linked list. I'm just going to squeeze this out a little bit. N7, N8, and N9. I'm also going to determine in my code the root, and it's 0. And unless I'm processing the root for a specific purpose, I'm just going to leave the root to be 0. Okay, I'm not going to mess with that. Now let's look at an algorithm which will allow us to loop through the linked list and print out each of the data items within the node. Okay, so I'm just gonna create a loop pointer here. As I just suggested, I'm not going to update the root. I might need that later. So I'm just going to create a loop pointer and set it to the same value as the root, because that's where we're starting. We're starting at 0. I could, of course, do this, but whatever, let's be fancy. I'm just going to say loop pointer is root, while loop pointer doesn't equal -1, because remember, as we loop through the list, eventually we're going to reach -1. We start at 0, then we go to 1, then we go to 4, then we go to 2, then we go to 7, then we go to 3, and then we get this value of -1. That's when we stop. We've reached the end of the list. So while the loop pointer doesn't equal -1, we're just going to print out from this list the value at the loop pointer index. Remember, we're starting with a loop pointer of 0. So this will print out list 0, which is this one, dot data. We want to print out the data, and I've called it dot data. So let's do that, dot data. Then we need to update the loop pointer. So the new value of the loop pointer is going to be the current node that we're at. Remember, at the moment, loop pointer is 0. So list 0, which is this node here, dot next node. That's the value that we want to get. And I've called it next here. And then that's the end of the program. So loop pointer starts at 0. 0 doesn't equal -1. That's true. Print list 0 dot data. So there we go, list 0 dot data. We're going to see 13. Loop pointer will be assigned list 0 dot next, which is 1. So loop pointer is now 1. While 1 doesn't equal -1, that's true. Print list1 dot data. So there we go, list1 dot data. That's going to print 15, and the new value of loop pointer is list1 dot next. list1 dot next, which is 4. So now we're going to jump to 4. So that's how that loop works. Let's run the code and see if we get the right result. Yes, we do. First, we start with the root pointer, 13. Then we jump to 1, which is 15. Then we jump to 4, which is 17. Then we jump to 2, which is 21. Then we jump to 7, which is 23, sorry. Then we jump to 3, which is 29, and that's the end of the list.